All right, so we have talked about domains from our graphs. When we're looking at a graph, what do we mean by the domain? Right, possible x values. So if I give you an equation, you could draw a graph and then look at that picture and tell me what your x's are. But we could also just get it from the equation. There's a couple things that we need to remember if we're talking about domains. In a fraction, what can't happen? We have a fraction. What's one thing that we can never have? If we type it in our calculator, it tells us domain error. What can't you divide by? 0. You cannot divide by 0, correct? So in a fraction, the denominator, the bottom of the fraction can't be 0. Okay, so things that we need to remember. In a fraction, denominator can't be 0. In an even radical, by that I mean a square root, a 4th root, a 6th root, and so forth. The radicand, the thing under the radical, has to be greater than or equal to 0. Because if you have a negative under a square root, what kind of number are you getting? We should know this. We've talked about this year. If you have a negative under a square root, what does that give us? If I say the square root of negative 2, how do you simplify that? If I told you the square root of negative 2, what would you have to do? What do you take out? We take out the square root of negative 1, which turns into an I. Remember that? When we have negatives under radicals, those are imaginary numbers. So when we are dealing with these, we only want to deal with the real numbers. That's why it has to be a positive under that square root. Otherwise, it would be an imaginary. Cube roots, we don't have to worry about that because you can do the cube root of a negative number. If I say the cube root of negative 8, that is negative 2. So it's only with those even radicals. If we don't have fractions or square roots, our domain is everything. So for our purposes right now, if I'm asking you to find the domain, there are only really 2 things we have to worry about. If we have a fraction, we know the bottom of that fraction can't be 0. If we have an even radical, we know the thing underneath has to be greater than or equal to 0. Otherwise, we just say negative infinity, positive infinity. So we have this handout with a bunch of different equations, and I want to identify the domains of all these without first drawing a graph. So if I look at this, I'm just checking if it violates any of my rules. If I look at number 1, do we have a fraction? No. Do we have a square root? No. So what is the domain of this? X can be any number you want. If I look at number 2, do we have a fraction? Yes. So our rule is if we have a fraction, the denominator can't be 0. My denominator is just 2. Do I have to worry about 2 equaling 0? No. So if I have a fraction, but the only thing underneath can't be 0, what's my domain? It can be anything. Okay. Let's look at the next one. All right, this time I have a fraction. that in a fraction, the denominator can't be 0. So I don't care at all about the top of the fraction, just the bottom. So if I'm solving that, add over my 3 and I get x cannot be 3. Now when we were writing our domains from our graphs, we always gave our interval. So I want to do that here. If x cannot be 3, your domain is telling us what it can equal. So it can be anything except 3. So it would be negative infinity to 3, union 3 to infinity. We can have anything smaller than 3, anything bigger than 3. Why did I do parentheses on the 3? Because it's not included. Okay? Bracket means included, parentheses is not. All right, number 4. There's no fraction, but this time I have a square root. If we have a square root, what do we know?
It can't be negative.
Right. My radicand, the thing under the radical, which is my x minus 1, has to be greater than or equal to 0. So this means x is greater than or equal to 1. How do we write that in interval notation?
Bracket 1 to infinity.
Yes, the equal to gives us a bracket. It's everything larger, so it goes to infinity. If you struggle with that, you could always draw yourself a number line too. That helps. Number 5. Actually, why don't you guys try 5 and 6? See if you can come up with your domains. We have some problems with number 5. You're writing the right thing, but you didn't finish solving it from the ones I looked at. We know if we have a square root, the thing underneath, so the 2x minus 3, has to be greater than or equal to 0. This is something we can solve. Add over your 3. And then what else do you have to do to get x by itself? Okay. If you think about what that means, greater than or equal to 3 halves says I'm starting at 3 halves and it's everything bigger. So my interval is bracket 3 halves to infinity. That's my domain. Anything from 3 halves on. Does that make sense, everyone? So make sure when you set up that inequality, you are solving it all the way. Also, just a thing, when we have inequalities, something to remember, if you multiply or divide by a negative in your inequality, what happens?
Yes, it's the inequality.
The inequality would flip. Yeah, so all of our normal inequality rules still hold.
So when you're deciding whether it's an and or problem, do you use the original direction of the inequality, or do you use the direction after you get it equal to, or after you get the inequality or?
For those absolute value ones, you would go by the original.
Okay.
All right. Well, the original one's the absolute value is isolated, not necessarily the x is isolated. All right. Next one, we have a fraction. We know in a fraction, the denominator can't be 0, right? If you're multiplying two things and you get 0, that means one of those things was 0. So tell me what numbers x cannot be. 2 and negative 1. So we have two numbers this time that x can't be. Now, my general rule, if there is only a single number that x can't be, I want the interval notation. If it's more than 1, I will allow you to list them. So I would accept it here because it's more than one value that x can't be. If you are going to write the interval, it's a little more complicated because it's everything except negative 1, 2. So it's everything smaller than negative 1, in between 1 and 2, and bigger than 2. So it's actually 3 pieces. So it would be negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. Like I said, if it's more than one value, I will accept either. If it's just a single value that x can't be, though, I want the interval. All right. Questions there? Let's look at the next ones. So still just following our same rules, applying them to all these different problems. When I look at this one, I have a fraction. Is my denominator ever 0? Nope. So what's my domain turn out to be? All right, number 8. I have a square root. So that means the thing under my square root, which in this case is just an x, has to be greater than or equal to 0. So I don't really have anything to solve here. This is just saying it's 0 and bigger. I get to ignore the plus 1 because it's not under the radical. So my domain is just bracket 0 to infinity. Look at this one. I have a square root, so the thing under my radical has to be greater than or equal to 0. What are your thoughts here?
Well, it actually would be better equal to -2 because.
Okay, so if you subtract over your 2, so x squared is greater than or equal to -2. Okay, if you have a square root, we do plus and minus. What's the square root of -2? If you have a negative, what do we have to take out? An I. Am I dealing with imaginaries? No. If we think about this, when you square something, you always get a positive, right? When is a positive bigger than a negative number? Always. So what's happening is inside my radical, it's positive no matter what I plug in. The only thing that makes it 0 is imaginary. So my domain is everything. Negative infinity to positive infinity. Number 10. What do I have to worry about? We have a fraction, so the denominator can't be 0. Okay, if I'm trying to solve for x, I have to factor this first. So it's only 2 terms. I could take out an x. So if we set those equal to 0, what can x not be? 4. And what about this one? Just a 0. Because it's basically each one of these can't be 0. When you have 2 things multiplied, the only way you get 0 is if one of those things is a 0. So, because it's more than one value that x can't be, then we know that x cannot be 0 and 4. That would be acceptable. If you chose to write the other notation, that's 100% up to you. It's telling me it could be anything except those. So it could be smaller than 0, between 0 and 4, and bigger than 4. So it would be negative infinity to 0, union 0 to 4, union 4 to infinity, if we did that. questions on that? Alright, let's keep trying. Number 11. So we have a square root. What do I have to do? Thing under the radical greater than or equal to 0. And then we're just solving this like any other equation. So we add over the 9, divide by 4. So x is greater than or equal to 9/4. So starts at 9/4, equal to means bracket, and everything large. So 9/4 to infinity is acceptable. Number 12. This one kind of has both things. It has a radical and it has a fraction. We know that with a radical, the thing underneath, so x, has to be greater than or equal to 0. We also know that if it's a fraction, the denominator can't be 0, correct? So I have to put those together. This one, if you square, we know that x can't be 0, and it has to be greater than or equal to 0. So when I put them together, what does that mean?
Bottom bracket to the inside.
Greater than or equal to 0 says 0 starting this way. Not equal to 0 says, oh, that can't be a bracket. I have to take off the equal to. It's just a parenthesis. Another way to think about it, if you have a fraction, all you're going to do is remove that equal to, because the bottom can't be a 0. So my domain is going to be parenthesis 0 to infinity. I can't put in 0 itself because that gives me a 0 on my denominator. And I can't put in negatives because that gives me imaginaries. I want to do another one that involves a couple pieces like that. Are there any questions on number 12? So on 13. If I'm looking at this one, we have a radical and we have a fraction. So we have to deal with both. The radical tells me the thing under my radical has to be greater than or equal to 0. The fraction tells me the denominator cannot be 0. Okay, so I have to worry about both of these here. If I'm solving this, if I subtract my 1, if I divide by a negative, what happens to the inequality? So I get x is less than or equal to 1. Okay, over here, if I subtract my 2, I get x cannot be negative 2. Then I have to figure out what that looks like when I put them together. Less than or equal to 1 would be starting at my 1, going to the left. But when I say not equal to 2, that means I cannot include the 2. So I'm going to have to break right here. I can have things smaller than negative 2, I can have bigger than negative 2, but I can't have the negative 2 itself. So when I put that together, that means my domain, I really wish I had a fly swatter. I can have negative infinity to negative 2, union negative 2 to 1. The 1 gets a bracket because it has the equal to. We took out the negative 2 because it makes the denominator 0. Does everyone understand that one? Uh, 14. We have a radical. The thing underneath my radical is a 2. Do I have to worry about that being a negative? just a number. It's already a positive under there, so I don't have to worry about that. I don't have any other radicals. I don't have any fractions. So what's my domain? I want you guys to try the next two. Okay, so on this one, we have two things, so we have to worry about both. The first one, so radical, so x minus 1 is greater than or equal to 0, so x is greater than or equal to 1. So if you think about a number line, I already know it's starting at 1 and it's going to the right. Second one, we have a fraction, so the bottom can't be 0, so x can't be negative 3. Okay, negative 3 is all the way back here. If you're already bigger than 1, do I have to worry about the negative 3? No, because I've already said it's over here, so the fact that it can't equal negative 3 is already taken care of. So my domain is just 1 to infinity. Now, if I had said positive 3, then we would have had to worry about it. We would have had to take that out. But because I already knew it was a bigger than 1, the negative 3 didn't change anything. 16, we have a radical, so the thing underneath greater than or equal to 0. If I subtract my 5, when I divide by negative 2, what happens to the inequality? Okay, if you need to draw a picture, less than or equal to would go to the left. So my domain is negative infinity to 5 halves. And the 5 halves gets a bracket because of the equal to. All right. Questions on those? So, your homework is the back of this handout. There's 12 more. You guys have time to work on that and ask questions now.